Kathy has already, I reckon, hit the record button. There you go. Just so anybody who misses this can catch up, or if you want to review what was said. So we had a really good session last time, and we did cover quite a bit at a fairly sort of general road safety philosophy level, and that was good. But you remember at the end we sort of looked at exposure, likelihood, and severity, and that's really where we're going to pick things up from today. And today's session has a few objectives here. We want to delve a little bit more into that kinetic energy thresholds for different crash types. We did talk about it. We saw some graphs. We had Usain Bolt running into cars, and we had people running into pommel horses, and then we had all sorts of other crash types that we were starting to think about. Well, we're going to look a little bit more at that and at intersection design and forms and how it might influence the energy at these intersections. And so by doing that, we'll look also at things that align highly with safe system principles and intersections. And we'll do the same for mid-blocks. And mid-blocks is a term we just use for areas between intersections. And that's the road network is made up of intersections and mid-blocks. Now, of course, remember your wallies, count your wallies, and hopefully you did the quiz and you got the wallies right last time. There weren't too many tricky hidden wallies, so we should be pretty good. Okay, there was some questions that came in and were asked around sort of contextualizing safe system assessments. So I'm just going to pop this up to help you out before I jump into some content. So road safety audits are something that a lot of people have heard of. Some of you, I think, do road safety audits. Some certainly procure road safety audits and or have heard the term. And that's an independent assessment of a road transport project with the aim to identify safety deficiencies. There's also quite a process in anybody that does a road design, a highway design, a bike lane design of having that review process done so that somebody else will look at the design, redo calculations, check things make sense. And there's some overlap between that and road safety audits. But there's definitely elements that sit outside that. Safe system assessments are a separate but overlapping entity. And I just wanted to contextualize that yes, there is a fair bit of overlap between a road safety audit and a safe system assessment, but there is quite a bit that sits outside here that is part of a safe system assessment, so what is looked at or how it's presented or the outputs that is different to a road safety audit. And in fact, we know that they can complement each other quite well. And I'll cover that in our final module as well, sort of when you would do these different exercises. Other terms you might have heard: safety and design, a safety and design review, or safety and design workshop, which is really looking at can the new road or the new intersection be built safely? Can it be maintained safely? Can it be decommissioned safely? And then some sort of, there's often DDA is a term, Disability Discrimination Act, which some jurisdictions use. I can't remember exactly what it's termed in New Zealand, but it's that sort of look at, can all road users of all abilities use the new facilities? So be that people in wheelchairs or vision impaired or the like. So there are these lots of different sort of independent road safety sort of assessments and looks at projects, and safe system assessments are one of them. So hopefully that answers a few questions that were lingering around, but I just thought I'd put that out there now, and now we can jump into talking about the intersections. As per usual, throw your questions into the chat at any point. Kathy will feed them to me as we're going along. And if any, I'll ask some questions. And fairly shortly into this, I'm going to give you a little exercise to do, a bit of time to think about the design of an intersection. And I see in there CPTED assessments is probably the DDA one in New Zealand, an acronym there. And I'm going to give a prize for the person who can tell me what that stands for.
Does that mean you know the answer to it, Ken?
I don't. Crime prevention through engineering design. Right. Okay. Well, 2 prizes because that came in pretty much at the same time. That is a different thing altogether from a DDA, as I understand. But yeah, that would fit more, I think, a little bit into safety in design and thinking about that, personal safety, crime prevention style stuff within your design and things like, underpasses and lighting and all of that sort of important stuff to think about. So yeah, lots of different assessment types out there. Some would say too many, but yep, people are trying to push their policy agendas and make sure different important things in society are covered, and assessing that people have thought about that is one way to do it. Thank you. The list of prizes grows, Kathy. Okay, let's have a look at intersections. And intersection crashes are quite prevalent on the road network, and we know that intersections obviously pose that risk because of the conflict points, and you can see there a crash happening, which is the conflict we're looking at. But I suppose a lot of people aren't as aware that intersections generate quite a bit of runoff road crashes as well. And the reason for that is that as people make mistakes around intersections, other road users or the other parties will try to avoid those mistakes and will often leave the road in their loss of control and then run off the road and hit trees and power poles and signal pedestals and all sorts of things. So it's not just about that crash, but we're thinking about also the secondary crashes as well. Now, Monash University Accident Research Centre came out with these sort of principles, high-level principles of intersection design. And I think they're worth looking at, and just sort of because they really do step back at a bigger picture, because they're starting there with fewer vehicles. Interesting way to start thinking about intersection design is how do you get fewer vehicles? I mean, now, if we look back at our exposure times likelihood times severity, fewer vehicles changes the exposure to crashes because less people are exposed or less vehicles. Fewer intersections isn't probably another exposure as well. So can we close off intersections and thus we're not exposed to crashes because there's no intersection there? And we do in New Zealand and across Australia have a tendency to have a lot of free and open access to our network in terms of lots and lots of minor side roads accessing onto larger roads. So lots of intersections. Whereas if you can step back at a transport planning, strategic level perspective, and you can sort of start to eliminate that direct access, move those vehicles to one collected, safer access point that's been well treated, you're doing a really good job. So yes, they need to access that network, but how many intersections do we need to provide? And that's a pretty sort of basic strategic transport planning concept, trying to minimize your access points in your intersections. But then once you've got an intersection, you're starting to look at fewer conflict points per intersection. And I'll talk to what a conflict point is shortly and show you some conflict point diagrams. But this is going to reduce the likelihood of crashes. Less conflict points means less chance of a crash happening, less likelihood that the crash happens. Okay. And then we get into severity now. We're assuming crashes happen. And we're talking about the biomechanically tolerable levels. And you see there that we're starting to talk about angle. This is for passenger vehicle, and speed. And angle and speed are big determiners of severity when we're talking about passenger vehicles and intersection design. Yes, there are more, I suppose, layers to that onion in terms of the driver's frailty, the protective elements of the vehicle, has it lots of airbags and those sorts of things. Those are there, but our intersection design doesn't influence really those. But what we can do is influence how fast people come into that intersection and what angles they come into that intersection. And if you think back to your year 10 physics, and you might remember vectors, and vectors basically saying that if you've got that crash or that intersect, we have a lot of energy pushed into the two. If you're able to get more angle on that crash, more energy goes out into the environment. So really it's a bit of that bounce off. And I think that's probably fairly logical. But we do think about that in our intersection design as well. Then we talk about vulnerable road users, being pedestrians and cyclists, motorcyclists as well. We call them a vulnerable road user. And we're looking to try to get speeds down to around that 30 kilometre per hour or below. I think that's hard, and it often very much is, but that's our sort of biomechanical threshold we're aiming at. And then finally, where the above speed and angle combinations cannot be met, crash risk must be reduced to a negligible level, which is sort of a generic statement, but I'll show you a little bit later how we can sort of start to think a little bit about that. So I've put some more tables into your notes here. You remember from last module, we had that lovely colored one with crash types and different colors. And I think that should be very helpful and something you'll be turning back to when you start to do your mock safe system assessment. But you can see here sort of generally this is cars, 40 kilometre per hour, any sort of crash type we generally say is within tolerable levels for the energy, car versus car. It's all happening within tolerable levels. And it just sort of the right angle sort of peaks out at 50. 60 kilometers per hour when you can get a bit more angle on that crash and a bit of a bounce off, bit of energy out into the environment. And that reference there to ChemX or XChemX is a thing called the kinetic energy management model. So it's just puts a bit of that physics and the equations behind it into a model. Now, for a safe system assessment, you would never need to go to the level of detail of doing XChemX modeling of energy at an intersection. But what we're really doing is just sort of being that high level look, and we know some general energies that we're talking about. Rear ends, head-ons, we're talking around the 70 kilometre per hour mark. And it's really very difficult, if not impossible, to operate an intersection where cars are going to collide, where a bullet vehicle speed is 80 and we don't have speed of the other vehicle. You can operate intersections above 80 kilometres per hour as long as your change in speed in the crash is different. So let me explain that. If you have a vehicle that accelerates up to 100 and comes in, and you have another vehicle up here going at 110, for example, we've got a thing we call our delta V, which is our change in velocity, would be 10 kilometers per hour. And so that then is the representation of our energy into the energy equation. You've got mass and you've got a few other things, squared. But the instant of that crash is not going to have enough energy transfer to be killing or injuring. Yes, you've got to think about then where they go and to the roadside and all of that, absolutely. But that first crash is within our tolerable levels. So it does give us hope that we can run intersections at higher speeds, and you'll know your motorways, your on-ramps and things operate when they're free-flowing and the like. The first crashes at those are sideswipe style crashes, and they're low energy. The secondary crashes are often quite bad, and we need to work on those. But so when a new intersection is proposed, or alterations to an intersection are proposed, or you're looking at an existing intersection for that matter, you can start to do very rough looks at what is the angle the crash will happen at, and what are the speeds the vehicles will be traveling at. Now, you don't need to be this precise. I'm going to cross over there. It's precise. You can really just sort of say, you really just sort of say, oh, well, this vehicle's sort of coming out there, and that vehicle's coming along there. That's pretty close to a right angle, isn't it? And so I'd be thinking about, well, which is the bullet vehicle? And I go, well, this is the bullet vehicle here because they're going to do the damage. They're the ones traveling along. This is the minor road. And we know that right angle is somewhere around 50 kilometers per hour is what we're hoping, or less. Then I might go, okay, well, what about the other side of the road? And I go, okay, well, they're actually going to get a bit of angle on that crash, aren't they? So I'll be more comfortable up to 60 kilometers per hour on that crash on the other side. So that's just sort of the, simplified thinking of it. And I've just done cars there. Obviously, if we start to think about pedestrians there, we've got we've got pedestrians crossing the road here. Maybe we'd be saying, well, we definitely want 30 kilometer per hour and assurance of that 30. And how do we do that? Maybe we've got pedestrians that are going to cross here, and we've got to start thinking about that. So, we do a lot of thinking around speeds, angles, and the users involved in crashes. And remember, all of this is in the severity side of things, and we are assuming the crash happens. Why? Because we know humans are fallible. And we're going to work really hard to make this good from a crash reduction perspective in terms of, lighting, signage, making sure, it's all clear and the like, but we just still need to get our head into that assumption that people are still going to stuff up. And I talked to you very briefly there about secondary crashes. This looks like a, nice, well, I shouldn't say nice, but a very, very right angle crash. And then, even that crash, we know the resulting sort of vehicle mass goes out that way and runs off the road. But we do also know that there's so many crashes, they'll come along and they'll avoid, or they'll clip this vehicle or clip that vehicle, the back of it, the front of it, or maybe miss it altogether, but they go off the road. So it's quite sort of chaotic event when this turbulence happens at an intersection. And so, well, this is some work done by, again, the Centre for Automotive Safety Research in Adelaide, and you see vehicle 1 coming into an intersection, vehicle 2. So they took a whole lot of intersection crashes that involve secondary serious injury and death on the secondary crash or run off road, and you see there when they reorientated them all to this axis, you see that the crashes generally occurring in those areas. Did they need to do a big study to tell us that? Probably not. It's pretty obvious, I think, and most of you, I'm sure, would have come up with that if I'd said, had it blank, and you would have said, well, the crashes are going to be there, aren't they? But you do see some, rare, odd ones But just the point to take away out of it, I think, is that even if you've got an intersection, there's a risk of runoff road as well. Runoff road crash, lane departure. So remember to think about your speeds and your angles, as well as all those things to reduce the likelihood of crashes. Okay, so I'm going to jump into giving you a little activity to do here, and it's a bit of fun, but it's also going to get you to start thinking about some things associated with exposure to crashes, likelihood of crashes, and severity of crashes. Now, maybe before I start explaining it, I'll just check in with Kathy to see if there have been any questions, and then I'll get into explaining this, and then you'll have a good 5 minutes or so to have a think about it and jot your ideas down. So I'll explain the exercise, and then you'll get into it. Kathy, anything?
No, all good at the moment. Thanks, Ken.
Okay. Here is our intersection. We have this existing intersection here, and for those of you who are sort of transport planning engineers or road designers or the like, you're just going to be jumping into your usual mode of thinking about what changes could happen in this intersection. For those who don't sort of play in that space, don't get too concerned, because it's all just your freedom to alter this intersection as you would like. But I want you to be thinking about it from those principles we've been talking about. But let me give you some information about this intersection. Well, actually, I'll come back to some information about the intersection. I want to show you some ground level photos here. So there you go. That's some ground level photos of our intersection there. You can see intersection. You can see it's got a bit of a service road here. It's a two-way service road. That's a bus stop over there. Got lighting. It's got a turn lane you can see here. Let's jump to the other side of it and have a look. There we go. Looking back now, you can see there's the intersection, or there's the road coming in. This is like a shared use path, pedestrians and cyclists. Bit of a bike lane there, a bit of bike lane style shoulder. This is a drainage sort of culvert structure, which water comes in here and then sort of goes into this sort of flood basin area. So what I'm going to get you to do, you're not going to have as much information as you'd like, I'm sure. I will give you some traffic volumes and a few other things shortly. But what your task is to remove fatal and serious injuries at this location going forward. Just, we don't want any. Get as close to that as you possibly can. I'm going to give you a budget, and your budget's going to be $3 million. It does sound like a lot if you're not in the infrastructure space, but building infrastructure is very expensive. And so $3 million doesn't get you too far. But some of you are probably going, well, I don't know how much things cost. I can't do this exercise. Don't worry. I am your cost estimation tool. You can write anything you want to do into the chat, and I will give you a cost for it. So if you say you want to do a big flyover, like a grade separation flyover interchange, and one road goes over the top and the like, I'll go, yep, no, that's great. That'll be $62 million. So you cannot afford that, right? But you might say, well, I want to put up a couple of signs, and I'll say, okay, well, that'll be $3,000 for deciding where to put them and buying the signs and then doing some traffic management and putting them in. So you've got this budget of $3 million. Another constraint you've got is you cannot close this intersection, because I know some of you are thinking, oh, we just went through that the Monash University Accident Research Centre's ideas and less vehicles and less intersections, can we just close this off? Close that off and close that off, and hey presto, there shouldn't be any intersection crashes there, at least between vehicles, and that's a good start. It's good thinking, good principles, but we've done the community consultation. There's not good access in other areas. So fortunately, it has to stay open, and it has to stay open so people can access it from both directions and get out and head both directions. The third point there I've got is we need you to operate in your current political framework. So what do we mean by that? Well, if you are proposing something radical, something new, something that hasn't been done in your area before or the like, I want you to maybe add in some ideas on how you can get this through the system. So how could we convince your boss, but also the community, the politicians, that this is the right thing to do, if you've got any ideas around that? So we're trying to think of things that we might actually be able to get in place. And so when you come up with a treatment, whatever it is, so let's go back to that sign. You know, you're going to put a warning sign, say you want to put a warning sign at the intersection back here. Intersection ahead or something. Okay. I want you to type that into the, when you get to your ideas, type it into the chat, say, you know, intersection ahead warning sign, and then just put either a little E or a little L or a little S to indicate that's going to influence the exposure to crashes, the likelihood of crashes, or the severity of crashes. Now, if we were to do a warning sign, for example, I'll give a prize. Who can tell me? Exposure, likelihood, or severity? What are we going to influence? Exposure, likelihood, or severity? Okay, Michael was first in, closely followed by Jack. Oh, and they're all flooding in now. Michael's our prize winner on that. The likelihood is absolutely right, okay? What we would attribute there is to say, if we warn people, okay, they will just be a little bit more alert, potentially, and they're less chance of crashing. Now, you could, with a little bit of a long bow, say, oh, and they might go a little slower, and so that could end up with severity. We don't tend to try to, you know, be too, you know, do the sort of tree diagrams and get all the way to every little thing. We just say that's a likelihood factor, right? And the reality is, we know that it's a small reduction in the chance of a crash with a warning sign. Yeah, if we activate the warning sign, so we give it flashing lights when there's danger ahead, you know, when a side road car's coming in, it's a little bit more effective in the likelihood. But anyway, that was just an example. I didn't want to, you know, but you're going to think about whatever you want to do with your $3 million, and you're going to say, type it in, your idea. You could do multiple things, but for each of them, put, is that going to affect the exposure or the likelihood or the severity, or a combination? Now, this road is carrying about 21,000 vehicles a day, and this road is carrying about 1,800. This has got 10% commercial vehicles, CVs, commercial vehicles, heavy vehicles. What else can I tell you? It's a 70 km/h speed zone here, speed limit, and it's a 50 km/h speed limit here. Down here, about 400 meters is a school. It's residential areas all around here. I think that's probably, oh, there's an intersection maybe a kilometre up the road here, up this way, which is traffic signals, and another one about 2 kilometres down this way, which is traffic signals. Happy to answer any questions people have about the intersection or the task, or as we've had just come in there, how much for a roundabout with raised platforms? A roundabout to meet the current Austroads Guide to Road Design Part 4B. Is it Part 4B roundabout? Somebody, yep, I think it is Part 4B. Will cost you $7.8 million, and adding raised platforms to that roundabout makes it $8.1 million. So to get a full-size roundabout, this is a B double route. That full-size roundabout is beyond your budget. So if you want a price for something, just write cost, please. Otherwise, I'm going to give you a bit of time to have a think and write what you would like to do into the chat with exposure, likelihood, or severity. I'm seeing some stuff come in now. I'll monitor this, and any that come in with a question for price, I'll do it. Is that drainage channel to the south of the intersection? Yes. Remember to put an E, an L, or an S. I'm seeing some good ideas. I'm seeing some of them categorized.
Can you give us a price on traffic lights and a raised table?
Sorry, traffic signals and a raised table, raising the intersection. Yeah, okay. So traffic signals will be 2.5 million, and another 400,000 for raising while you're out there, because you've got everything traffic managed nicely. So just under your budget there to do that. It's quite well set up for traffic signals in that sense. So yeah, just signals 2.5. I saw another question came in. Remember that exposure, likelihood, and severity. I'll give it another minute or so. I'm loving what I'm seeing coming in here. Loving the fact that people are really starting to get into that exposure, likelihood, and severity allocation of infrastructure. Price on RIOR, a rural intersection activated warning electronic sign, or that side road activated speed sign. Well, we'll go $300,000, $350,000. Might be a little under, might be getting a good deal there, but you can certainly afford that. You just need a bit of ITS and radars and loops and things going on there. That's why some of you are probably staggered by the cost of that, but there's a little bit of stuff behind the scenes there. Is banning or restricting movements exposure or likelihood or both? It's an excellent, excellent question. So in a pure safe system assessment, we would really say that restricting movements is likelihood. Banning movements is exposure if you believe that that will actually not happen. So if you just put up a no right turn sign, but it's still open, and you go, well, people are going to, drive a kilometre down the road to turn around and come back, and they're just going to turn right anyway. Then you put it as a likelihood. But if you maybe built across there and actually physically stopped, then you would be able to either put that as exposure, well, probably exposure, because you're lessening the number of people exposed to that crash type. All right. Well, I think I'm going to so I'm just reading through them at the moment. I'm loving it. What a great group. So many good ideas, good categorization. I'm going to chat about quite a few of these, I think, because we've got some good ideas. But let me just whip through and sort of summarize. I'm sure, and thank you, most of you have been putting it out to everybody, so others can be going back and reading this as well, which is nice. But we're seeing, there was the idea very early on there of a roundabout possibly, and sort of thinking about that. That's interesting. And the idea of this raised platforms and raised safety platforms is quite prevalent in the comments coming in, and that's interesting. Raised pedestrian crossings even. And certainly 5 years ago, if I had run this course, which actually I did used to run this course 5 years ago, nobody would suggest raised anything. That's crazy talk on a road with 21,000 vehicles a day, but we're seeing lots of them coming in now. That's interesting. I might talk a little bit about that shortly. We're seeing lots of people now starting to talk about signalization, the traffic lights, so traffic signals, and quite a few people nicely putting that towards the likelihood of a crash. Okay, so the likelihood of the crash is, if the signals influence the likelihood of the crash. Some people want to say it would influence the exposure because, red light, then they're not exposed to that. But remember, one of the key principles, people make mistakes. We're going to have people running red lights. So we're actually just reducing the chance that they will, that they will crash into each other. So likelihood, that's good. Okay, so then we had the variable speeds and the side road activated speed, and people sort of saying, oh, well, I think that's severity, and some saying it could be likelihood, some saying likelihood and severity. Now, we would probably attribute it to likelihood and severity, because reducing the speed through a mechanism like that will reduce the chance people crash, because they've got more time to see an issue, react to it, avoid it. And then, but if they do crash and they're at lower speed, the severity is down as well. So sort of double benefit for things that have that serious reduction in speed or a decent reduction in speed. So extending the median across the intersection, banning the turns. probably just either, as I said, a likelihood or an exposure. But do remember that one of our rules was that everybody has to be able to get in and out from both directions. So unless you are adding some sort of U-turn facilities very close by or some appropriate ways, that probably doesn't meet the design brief there. So I'm just flicking through. I won't get to everybody's here, but I am enjoying, really impressed with this. So we had some options there. Some really good ones associated with adding cycleways to the service lane in order to alter the exposure potentially of cyclists to the higher speed traffic, or maybe the likelihood because of course they are going to need to cross and be exposed at some point to these vehicle crashes, even if you had that as a nice separated one. So potentially a likelihood reducing factor there. The only way we could reduce severity associated with that is if we had some sort of speed reduction. So maybe at this crossing point, if this was raised or something like that, we'd have a severity reduction as well, if it came through like that. Roadside barriers. Okay, interestingly, roadside barriers, if we were to put roadside barriers down the side, that is very much just a severity reduction, because the chance people will crash is still the same, because hitting the barrier is a crash. And in fact, some would argue that the chance of crash goes up a little bit by putting the barrier in, because you leave the road, you're definitely going to hit the barrier, but maybe if you left the road here, you might be able to recover. But the severity of the crashes goes so significantly down. Instead of going into this drainage ditch or hitting this tree, you're directed along the barrier system. So it is attributed just as a severity reduction technique, but a very, very effective one. So we've got some discussion around speed limit, and yeah, as I talked about, severity and likelihood. Wow, great stuff. Some alterations to the keep clear markings is put in there, and that's an interesting one. So there is a keep clear there, and changing that around, we would say would alter the likelihood of the crash, just the likelihood, and that was correctly put in there by us all. Okay, well, let me talk a little bit about some of this, and I'm going to come back to this intersection after I go out and have a look at a few other intersections. But I really thank you all for that wonderful input. Really good stuff. Kathy, I'll let you monitor the chat there, and if anybody wants to add anything else or ask questions. But let me talk about a few of the things that were brought up there. And one of them was traffic signals. And it was kind of brought up there pretty early on. People started wanting to signalize that intersection. And I mentioned there, we know that that is a likelihood factor, just likelihood. And you'll see this little box that I use often if I'm talking about a infrastructure technique to reduce risk. And I'm going to sort of explain where we're getting the benefit from that. So we know that it reduces the likelihood of crash. People obviously have a green, they go, they've got a red, stop, and you can add things that improve the likelihood. So as in make it more unlikely that a crash will happen, things like fully controlled right turns or the like. But the thing is that we know by putting traffic signals out there, we do reduce the chance of crashes happening. We don't eliminate crashes. And this is just a heat map of death and serious injury. So the more intense the heat there, the higher the death and serious injury at this location. And this was for a 5-year period in outer suburban Melbourne, but I could have just the same, take an outer suburban Auckland or Christchurch or Hamilton, or anywhere where there's reasonably large arterial roads with a bit of speed up, and they cross each other, we see a signalized intersection. All right, these are all signalized intersections. Signalized intersection. That is where the majority of our death and serious injury is happening, in these outer areas. And in fact, if you took New Zealand, and I haven't done this, but it'd be interesting if somebody did, and looked at your top 100 intersections for death and serious injury, the bulk of them will be large signalized intersections. And the reason that is the case is because, well, we do have a lot of traffic volume going through here. So the exposure to crashes is very high. We've got high volume and high volume. But people are running the red lights, making mistakes. These are not occurring because the traffic signals have failed. These are occurring because the humans have failed, as we know they will continue to do. So the challenge we've got is, though, that there's a lot of our industry believe that that is sort of the ultimate intersection treatment, until we can probably get to a grade separation, a flyover or the like. But a signalized intersection, we don't know. Okay, we maybe want to put there some other little bits and pieces, maybe a red light camera, maybe a some mast arms and all these other bits and pieces. But these intersections have pretty much got it all, because for the last 30, 40 years, they've been the source of death and serious injury. And yeah, we keep adding little bits and pieces to it to try to lessen the likelihood of crash. But nobody's been saying, what about the severity of these crashes? Can we reduce that? And this is where we need to get to, and start to say, okay, we know a traffic signal reduces the chance of crashes, but we need to do more. What about roundabouts? Well, roundabouts do this wonderful job of reducing the severity of crashes. Okay? And why is that? Well, it's interesting. The severity of crash comes down significantly. I'll come back to a few other ones. Because we have a reduced speed, because vehicles slow down on the approach to it. All vehicles from all directions slow down on the approach to it. They're more alert, and we have better crash angle. I'll show you those in a few diagrams shortly. But there is a bit of a sort of traffic engineering challenge with roundabouts. And the location that you had, well, first thing was the cost. Now look at how sort of big this is. Obviously not the same site. Big amount of pavement, isn't it? Big splitter islands, huge. And in fact, at that site you would have to be acquiring houses, massive changes to the services and relocating, huge costs. And the reason roundabouts need to be this size, according to the Austra's Guide to Road Design Part 4B, is because a large vehicle needs to be able to track around this, maybe even make a U-turn, okay? And they have a swept path, and it's fairly large swept path. And you'll all know that as you see a large vehicle trying to turn, make a turn, they swing out very wide and they come around, and that's their swept path. So that's why they're asking these to be so large. There's also a little other traffic engineering challenge we have, which is unbalanced flow. So roundabouts tend to work when we have nice balanced flow. So there's sort of similar number of vehicles coming from all directions, because it works quite well in its circulating flow. If you have a dominant flow, for example, maybe this one is like we had on our other one, which was 21,000 vehicles, and very minor side traffic. It's what we call unbalanced, and the roundabout starts to not perform well. Either we just get this massive bank up of traffic on the side road that can never get out because there's just constant flow there, or we have the side road getting this beautiful free entry and exit, and we bank the main road. I mean, that's a very traffic orientated way of looking at things, but it's sort of the way it happens. Now, we do know, though, that you can get some wonderful benefits by what we call metering roundabouts, which is where you put some traffic signals. You don't need to put signals on all of them, but you can just put it on one or two legs. And then just when traffic banks up to a certain point, trigger the signals, let some of the traffic out, and you do it with all sensors. And it works pretty well. So that's that. And that also helps with some of the vulnerable road user challenges of crossing roundabouts. And we know that pedestrians have a lot of trouble crossing roundabouts. It's a hard judgment to make. It's certainly a major inhibitor in people walking because they don't like to have to make this judgment. Old people can't, it's very hard to judge, okay, are they turning in or are they coming in, all of that. Multi-lane roundabouts are hard, are even harder, near impossible for a lot of people to actually cross. And certainly I always marvel at some of the place in Hamilton that I usually stay in New Zealand, and I'm trying to get over to the, what is it called? What do you call this? My Countdown supermarket, and I got this sort of chicken run across this multi-lane roundabout. It's you really got to run sometimes, and it'd be near impossible. It would be impossible for a lot of people to make that. These and cyclists don't get a good run at these roundabouts either, from either a safety or a sort of perspective of them actually using them. So there are challenges, but from that vehicle to vehicle safety perspective, they are exceptional. But why? Let's go back to that, how big they need to be. And we do see little roundabouts like this. Now, this is in the UK, but what we have here is this roundabout, which is essentially just paint, isn't it? Okay, they added a little splitter island here, but this works because the vehicles can just track over it if they need to. But why on earth would this be beneficial? Well, it's beneficial because anybody coming in from any direction does not believe they have ultimate priority. And ultimate priority is a real danger for us, because what it means is that they are driving along at a constant speed, somewhat lacking attention to potential crashes because they've got a green light, or the side road's got to give way, and so they're just continuing on their merry way. Immediately by this configuration, people go, oh, I'm going to look around. Is it safe for me to go? And that's actually, it's subtle, but it's wonderfully effective. The US uses this very successfully in a four-way stop scenario. And as I understand, you've got a handful of those in New Zealand as well. Love somebody to send me a photo of one of those. But it's the same theory, is that you're not just giving ultimate priority to one road user. People often get concerned about the speed vehicles will go through that. So if I go back here, it's a fairly straight run through there, isn't it? Why slow down? Have a quick look and, put the foot down to go through. So are we losing some of the advantages of that roundabout in speed reduction? Well, you can do things like raised platforms. And that was very nice to see somebody talking about a roundabout with raised platforms. It was quite a good one there. So this is really sort of trying to address some geometric challenges you might have with the roundabout by saying, well, what is the principle we're trying to achieve slowing vehicles through there? You can also sometimes combine that with a pedestrian crossing. That's a pretty wonderful way to do things as well. But with what we're talking about here, a whole lot of things to reduce the severity of crashes, aren't we? Severity reduction. So there's less conflict points at a roundabout. You can see there's less ways to crash at a roundabout. So each of those dots is what we call a conflict point. Lots of conflict points at signalized intersections. Now, often people go, well, if there's less conflict points, there's less likelihood of crash. Now, in principle, we tend to agree. What we've discovered, though, with roundabouts is we have quite a few rear end crashes on the approach, which aren't put there as sort of direct conflict points as such. And we tend to say that a roundabout is going to give you about this. So if you've got a give way, a yield controlled intersection or a stop sign controlled intersection, and you put a roundabout in, you're probably going to get about the same amount of crashes. The severity of them is just going to be incredibly low because we've concentrated them to rear end style crashes or good angle crashes. The angles of some of these crashes are really horrible, especially those crossing ones, the red dots. So we really just attribute roundabouts to a severity reduction. And the angle of crash is so much more beautiful at a roundabout than it is a set of traffic signals for most crash types. People, when they crash at a roundabout, this is two cars I'm talking about, they bounce off each other, right? We don't want them to have a crash, but if they do, I want them to have a crash like that. The speeds are lower, the angles are better. And then there's this other little one, which I sort of alluded to, but when people drive, unfortunately, they drive in all states of consciousness. Some of them have, worked a double shift. Some of them have been at their brother's wedding and, done an all-nighter and had a half an hour sleep and then jump in the car and driven for 3 hours. Some of them have just had a big fight with their partner and they're completely altered in how they're thinking and the like. We don't want them driving in any of these states of mind. And unfortunately, there's a huge amount of that does happen. But it's amazing when you put something in the road, like a roundabout, and even as I've talked about, the signage and the way we make nobody feel they have priority, that people come back to reality. So, you can even have very, very fatigued drivers. And at that one point, they'll be quite with it. Well, more with it. They'll slow down. They'll look around. Right? We've brought them back at the conflict point, at the most dangerous point. Yes, there's danger all around it. And we've probably got runoff road issues and the next intersection down. But we are getting some pretty amazing benefits at this location. So the infrastructure can actually improve alertness and alter driving behavior. So roundabouts are amazing from this perspective. We know, though, not all roundabouts are the same. We know a single lane roundabout compared to a double lane roundabout performs much better. And the red line down here is a sort of single roundabout performance in terms of speed, which is always pretty good proxy for crash rate in a radius. And we see that single lane roundabouts operate really well. Double lane roundabouts, when they're fairly small, pretty bad in terms of speed through, but they sort of come together when you get them start getting them quite big. And then a turbo roundabout, which I sort of just put in for interest, but maybe not just for interest, but turbo roundabout is a 2-lane roundabout that you can pretty much get to operate as safely as a single lane roundabout. And so a turbo roundabout is a 2-lane roundabout where you have raised separators within the carriageway and on the approach and on the exit. So what happens if you want to do a right turn, you've got to get yourself in here and then you get in this bit and out you go. You want to go straight through, well, you could do that from either, but you want to go left, you get yourself in there and you go out that way. And what it does is it controls straight lining, drivers straight lining through there because you've got a physical island there, stop sort of late turn maneuvers and over motorcyclists and others, and or vehicle to vehicle. So you get quite a few really good advantages from turbo roundabouts. We don't have many turbo roundabouts in the Southern Hemisphere. Certainly very popular in the Netherlands, for example, which is where this photo's from. And I flipped it so it was drive on the left, because it would blow our mind if we were trying to understand that from a drive on the right scenario, which is what they do. But it is also interesting to see the cycling infrastructure, isn't it? That I wouldn't dream of putting a cyclist through that. But I think in Australia and New Zealand, we'd probably just try and get the cyclist to battle it out through there. We got another nice safe system assess snippet on this topic, and some videos of turbos operating if you want to have a look. There's another turbo roundabout operating beautifully. And I love this photo for many reasons, but one is this little incident going on here. Because we look at it, we go, oh, wow, okay, we've got some conflict happening, haven't we? Truck looks like the truck's pulled out in front of the car. Look at the angle, first of all. We don't know the speed from this static photo, but we'd be pretty confident it's a fairly low speed, isn't it? I mean, this vehicle is coming in. This is very much a radial style roundabout, so it's a fairly abrupt, slow movement to make that move. We know that if that crash was to occur, or if it did occur, the severity would be so low, wouldn't it? But if we had a cross intersection signalized or give way, and we had the same mistake happen, the speeds are high, the angles are bad, and we're potentially into that death and serious injury.
Sorry, just a quick question.
Sorry, speaking there, Kathy, can't hear any.
Yes, I am. Sorry, can you hear me now?
Yes.
How do you rate exposure likelihood and severity to pedestrians and cyclists when considering roundabout versus signals? Likely different outcome than just car to car.
Yeah. So certainly within a safe system assessment, pedestrians, cyclists, motorcyclists have their own exposure category, likelihood category, and severity category. So a roundabout will be analysed for crashes with cars, crashes with cyclists, motorcyclists, pedestrians as well. So we'll get that direct output from the safe system assessment. So certainly we would never be ignoring those road users in the assessment of safety when a roundabout's in. I suppose as I'm running through this, I am talking a little bit about car-to-car interaction to start with. I talk about pedestrians and cyclists in their own module next, and we do talk about roundabouts and ways we can really improve things for cyclists and pedestrians at roundabouts, because we know the roundabouts are wonderful from that perspective of slowing the vehicles and a whole lot of those other reasons. So can we get that as well as really good access and safety for pedestrians and cyclists? And we can really a lot of the time. So yeah, it's definitely accounted for, and I'll run through that a bit more later. But this is a turbo roundabout. Obviously, this is a big turbo. I mean, this is quite amazing. Looks complicated from up here, but I think, dare say, when you get on the ground, it would be far more intuitive. It's signalized as well. And this isn't, again, from the Netherlands. And I had this fun experience of, there's a Dutch engineer that we'd brought in to actually talk about cyclists and cyclists at roundabouts. This was quite a few years ago, and when we were doing some innovative cyclists at roundabout designs and the like. And I showed this photo to this Dutch engineer and said, "This is amazing. I think in Australia and New Zealand we would we would just have a large signalized intersection if it had got to that number of vehicles going through that warranted that many lanes, or it might have got to sort of grade separation, but probably just a big signalized intersection. And the Dutch engineer, in sort of typical Dutch dryness or Dutch honesty, sort of went, signalized intersection, but what about all the death and serious injury to your community? And it's like, yeah, I know. Yeah. And he's like, well, surely with raised platforms or something to slow vehicles down. I'm like, probably not. And it couldn't fathom that you would possibly run an intersection at 70, 80 kilometers per hour just with traffic signals. I mean, it could not fathom that. And they would rather something of this size, the massive size of this, but they know that every vehicle coming in there gets slowed down, navigates it in a fairly slow manner, and they can control it. So it's quite, it's quite impressive, really. I think just that difference in philosophy there. Now, Kathy, any other questions there? I just had an idea, actually.
No, not at the moment.
Okay, I'll find that in a second. I'll keep just moving along. So here's another pretty interesting one. This is it's actually a concept. It's not actually real, but it's a cut-through roundabout. But what I love is the fact that now engineers are trying to work out, well, how do we keep capacity through an intersection? We know a signalized intersection is going to pump more traffic through it. And on some roads, that is the objective. I don't know much of our road environment, we're trying not to pump more traffic through. We're trying to actually get people walking and cycling onto public transport, and then lots of good stuff like that. But there are still, traffic related areas. But how do you get traffic through an intersection, but still regain some of these wonderful things from a roundabout, which is, and this is a pretty cool example, I reckon, because what we're doing is we're slowing vehicles on the approach because they've got to navigate around this. We are waking them up if they're half asleep because they've got to navigate this as well. Even though they see a green light, they have to still navigate around something. So it's pretty exciting. Some really good benefits that can come out of that. No, that hasn't been built yet, but hopefully one day, if we are wanting to run some of these major traffic routes, continue to run them as traffic routes, then this is the kind of stuff we'd be expecting to see, or other ways to potentially slow vehicles. And lots of different little mock-ups. That's the Squircle, it's called, an attempt to do the same thing in a more confined environment. But I really did like to see that a lot of you were talking about race safety platforms. And as I said, genuinely, I mean, I've been running this course for about 15 years. For about the first 10 years of it, nobody was interested, which is fine. But we've got some traction now, and people are getting excited about this idea. And when the idea of safe system assessments and the safe system, which is wonderful, and the idea of a race safety platform would just be absolute no-no on a major arterial road like that. And, you could not possibly in the past have said that without being kicked out of any design office anywhere in New Zealand or Australia. Because arterial roads, well, you do not do vertical deflection, which is anything raised, on these major arterial roads. I mean, they are for the trucks, keep the speed up, all these traffic related, pump things through as fast as possible, freight, emergency vehicles going through there, and all of this sort of stuff. But we've certainly evolved now. We're far more evolved on this, and we know that we can create vertical deflection, raised parts of this, that aren't like your urban speed hump or your harsh ramp grade. We can use them to dampen speeds down as we want through the design, and get severity down a little bit, probably likelihood down a bit as well, but predominantly we're talking severity on these. In that intersection that you were looking at, and some of you were pretty spot on there, was they were thinking, well, signalisation's probably right because we can't afford the big roundabout, and we could look at a small roundabout. But they went, well, we've got signals down the road, and we've got signals down the road, and we've got unbalanced flow, and we want to provide better connectivity for pedestrians across and cyclists across, and all of this. They came up with this idea. Well, we want to go with signals, and they were, I suppose, advanced enough. And this is, it's 8 years ago now, so 10 years, maybe even 10 when they started planning it, to say, well, we know that the signals down the road have a crash history of serious injury. We know the other ones do. We know signals, people run the red light. What can we do to that severity? How can we alter the severity of the crash? This is great. Like this was our real sort of first time that anybody was meaningfully talking about severity of crashes when signalizing major intersections. And they came up with some raised platforms. They thought about raising the whole intersection, but then realized, well, they don't need to do that, because which is the bullet vehicle? This is the bullet vehicle. This is the bullet vehicle. These are the target vehicles. We don't need to influence their speed. They're not going to be the ones doing the damage. So we just need to slow these ones down. Yeah, the cycling facilities aren't the best here. This is the artistic impression, of course, and I always do artistic impression stuff. But they did build it. They did build it. And some of you may have seen that because it's certainly prominent in the Austroads Race Safety Platform document, which was produced by some wonderful New Zealanders. Again, exciting stuff. But this one, you'll see that advisory speeds, advising people to slow down to 50. Why 50? Because that's their side impact crash threshold speed that they're trying to achieve for passenger vehicle to passenger vehicle. Okay, they were a bit more pedestrian focused. It was probably a bit lower, but that's this is a fairly car dominated area. But by the signals and the raised platform, we're now getting both, aren't we? That's pretty wonderful. There is another picture of it as well. I was out there doing some post-opening road safety auditing of this and looking at it. And this, I thought, was a wonderful picture because green lights, lots of green lights. And the vehicle there is slowing down to go through the conflict point. And it's just, it's brilliant. Now, some people get really angry at this. They're like, why? They're just inefficient, slowing these people down, and for this very tiny chance of somebody having an incident and jump up and down. And you're like, if they'd built a roundabout here, everybody would have slowed down. Nobody would have complained at all. It's just we're not used to this. We're not used to seeing this, slowing people down through an area of risk like this. It's pretty exciting. And I love this one as well, because this is a sort of benefit that wasn't completely expected, but in hindsight, we should have expected it. But there is this thing called the dilemma zone, right? The dilemma zone is a period in time and space when a vehicle approaching an intersection, the lights turn orange, and the driver is in a dilemma. Do I put the foot down and go, or do I brake? And I'm sure you found yourself in the dilemma zone at one point driving around. And what you find actually is that the installation of the race safety platform just narrowed the dilemma zone a huge amount, because people they made the choice to stop because they were going to have to navigate over this, plus the reduction in speed. So huge benefit from that dilemma zone reduction as well. So that was pretty cool. And I'll take questions in a second, but here's your wonderful one just outside Hamilton. And I'm sure many of you have seen it. What a great example of exactly the same philosophy. Going to put a set of traffic signals in, and said, well, we can do better than that. We can reduce severity as well. And so let's go with the raised platform. And they went raising the whole intersection for one reason or another and some different configurations, but that's out there. And I think it's a wonderful example of there. It can be done and working pretty successfully. Kathy, any questions, anything I need to deal with? Because I just had an idea that I thought I might show this group something from my past within government that I thought might be of interest.
All right, you can do that, but I'll share my screen just for a moment because there was a question about raised safety platforms on arterial roads with significant heavy commercial vehicle volumes. What's your view on the preferred gradient? And then Daryl's chimed in with there's a really good Vic Roads guide for that. And is it this one here? Yeah,
RDN 0307 is a good one. And actually, there's also now the Austroads document, which, as I mentioned, was produced by some really great New Zealanders, which has a good bit of information in that. And we have some safe system of snippets on ramp grades for speed and heavy vehicle as well. So lots of resources available.
Yeah, so it was really just my opportunity to refer people to the resources part of the course in Moodle. So in there is where you'll see lots of different information.
Thanks, Kathy. Your audio is not great. We're hearing most of what you're saying.
Okay, I'll stop talking then.
That was not my point. It was to try and shout into your computer or something. Thank you. It's really good to, yeah, so there are resources available and feel free to share resources as well. I thought a nice little story would be to tell you about time I was working in the road safety department of Vic Roads. And there was a huge program called the Congestion Easing Program. And it was, I think it had a spin title like Keep Melbourne Moving, I think was its title. Basically, it was outer suburban areas, houses being built and very minimal public transport and any other facilities. So everybody's driving cars and more cars and congestion, and those areas were fairly high-ish speed, and they had roundabouts at big major intersections, but those were getting clogged and congested, and the analysis showed that clearly that if those roundabouts were taken away and traffic signals were put in their place, they would reduce the congestion. And I can't argue with that. That's pretty standard logic. So these designs that were ripping out roundabouts in these outer areas and putting traffic signals in were coming into the road safety department for review from a safety perspective. And what they were really expecting was a review of, okay, have we got the right signal phasing? Have we got good sight lines to the signals? Do we need mast arms? Is the line marking right? We've got pedestrian crossing facilities if there is pedestrian desire line, although there's really, sadly, not many pedestrians out in these areas. But anyway, so that's what they were expecting. But we sort of looked at them and started producing this memo, and I took a copy when I left because I thought it was pretty exciting. Hopefully, Kathy, you're seeing that memo. So the memo was from Road Safety Department, and then Road Safety Statement. So I'll zoom in here. The Road Safety Department has analysed this project as increasing crashes as follows. Project life, 20 years. Number of deaths attributed to this project, 2.3. Put a little people there to remind them that we're talking about killing people here. Number of serious injuries attributed to this project, 12.6 and more people. And then this little statement of acceptance. So the above road trauma is accepted by, and then so pop that on top of the project and send it back to the region. Now, I think you could imagine it caused a lot of controversy, and we never got one signed. We were told to stop producing this, but sometimes you need to sort of boil things down to a pretty basic choice. Now, the reality is that they were trading off human life for a little bit more capacity. And so nowadays, we hopefully don't need to be producing these memos, because safe system assessments should be doing the job of this, because showing that, you know, okay, we're ripping that out, it's actually going to increase death and serious injury, make things worse. But that certainly, yeah, I did get a couple of us got a good stern talking to from the executive director about the responsibility of a road authority is to manage balance off many things and blah, blah, blah. And you go, well, yeah, okay, we know that, but we've all committed to this safe system and to prioritising the health and safety of our community, and we're making a conscious decision that something that is more dangerous for other objectives. Now, I mean, that's a huge debate. That's a long debate to have, but it doesn't align with safe systems if you are going to make that conscious trade-off. So that's why we're seeing more of these raised platforms, that sort of thinking. And it's pretty nice also to see this one recently, which is a road with at least 50,000 vehicles a day, major bus route, heavy vehicle route, emergency vehicle route, ambulances, fire trucks. This other road is about 30,000 vehicles a day, and that's their intersection. And the intersection is raised. So that's it there. You can see it's raised. Now, it's not raised like a urban speed hump. It's a shallower grade, but it's trying to dampen speeds down, wake people up, make them very alert as much as possible as they approach this intersection. So that's pretty exciting. And what's more exciting is that used to be a roundabout, and it was too congested. And they said we're ripping it out and putting traffic signals in. And they gave a stock standard signalised intersection design, and that was subject to a safe system assessment, because all projects are subject to safe system assessments now in the Victorian government. All projects are that size. And the safe system assessment said, you're going to make things worse. You're going to kill people. It's going to seriously injure people through the scoring and the way they did it. We suggest you make it a raised platform. And they accepted it. So pretty exciting sort of evolution in the whole process, as well as seeing the infrastructure, and as well as showing that you can do it on massive volume roads with all of those challenges, and it works. And it's not, easy to go. Houses, so people go, oh my God, the noise, and there'll be so many rear end crashes, and people are going to hit it, and dukes of hazard flying off. None of that plays out. That's all just what people, sort of conjure up in their mind as fear of something new. But it's always very hard to get your first ones in. But now there's enough of them out there, and there's enough ostrich guides and things that it's very acceptable. And that's that road design note that was mentioned, and it is in there. And there's the Austroads document as well, which we can point people to, but you can just search that, Raised Safety Platforms, Austroads. You'll find a wonderful document there with lots of examples. And it is really, I think, one of the great examples of how our industry can change. We can progress things. We can start questioning just the run-of-the-mill operations that has inherent death and serious injury, and start to alter that. There's the Austroads document. And what's right on the front cover of the Austroads document? Lovely intersection in Hamilton. just outside Hamilton. What is the intersection? It's Gordonton. Somebody will know. Gordonton and something. I went out there with Simon from Hamilton City Council, Simon Crowther, in the design phase to have a look. It was wonderful. Great to see. I've just seen pictures of it. I want to get out there. When your immigration lets people in from other countries.
Not long now, Ken. Can you hear me better now?
I can. Beautiful, loud and clear.
Terrific.
Yeah,
okay. Melanie says it was Thomas, Gordon and Thomas. Maybe.
Thank you.
And
Prize
for Melanie. Okay, quick question. When is it more beneficial to raise the entire intersection rather than introducing raised platforms just for the bullet vehicles entering the intersection?
Yeah, there's quite a bit of sort of design thinking around that, but certainly a crossroad tends to work better as fully raised. And if you've got that T intersection, it tends to work better for that raised safety platforms on the approach. It will depend on things like drainage and your drainage setup and some grades. You also got to think about larger vehicles. We don't like them to have to prop halfway up a platform, or so if you're doing these raised platforms on the approach, you need to make them quite long depending on your design vehicles. So there's quite a bit of sort of design specifics about that choice. So I can't sort of categorically just say this type and this type. So yeah, it gets into your details of design, but have a look at that Ostrich document, some good information in there. I can probably send some designs of some of those bigger raised intersections if that helps people. And we are just going to see more and more of this design guidance come out for this sort of stuff.
Thanks, Ken. Sorry, it is. We do have half an hour to go, but I'll ask one more question. Keen to hear your thoughts on left turn slip lanes in signalised intersections from a safety point of view.
What a just beautiful question and a hot topic in industry. And there's so much debate. When we ever put out a little safe system snippet on something like that, oh my God, do people get angry? We get official complaint letters from people in industry on that, which is indication it's hot topic. The challenge you have with the left-hand slip lane, and I'm going to jump back now. That wasn't an extra Wally because I'm going back slides. Here's a left-hand slip lane, which some of you would have seen. The challenge you have with the left-hand slip lane is, as a vehicle's coming up here, where are you looking? You're looking out here to see if you can put the foot down. If you have pedestrians crossing there, you have what is generally bad news in road safety. You've got the car driver not looking where they're going and a conflict point. That's just simply bad news. Okay, so what we have discovered is that a pedestrian crossing, and we use the feet symbols and the zebra crossing markings, by itself, without this raised part, is generally considered not good, because pedestrians are less aware, as in less looking to make sure that, because they've got priority to cross. And we have the vehicle not looking at that spot at some point. So it's generally not considered good. If you raise it like this, it becomes quite good, because the vehicles slow down for this as they're looking, and then look back at this to navigate it, and there's more interaction. So that's good. And so we know that a raised, we call this a wombat crossing, but that raised pedestrian crossing is good. Signalising it could be just as good, as long as you've got it raised as well. Signalising it's better than this one, but without the raised part, gives you a bit of challenge. So there is some New Zealand research out of this from Royce. There's some Australian research from O'Brien. There's they're the two main ones that slightly contradict each other, although nobody argues with the fact that a raised thing is going to be better. So Queensland's come out with a statement that all will be raised or non-existent. But the reason that sometimes you just absolutely have to have them is if you have a B double or a really large vehicle that uses this route and you don't give them a slip lane, they sometimes can't get around. They just cannot physically get around this turn. So providing them the slip lane provides essentially help for their swept path. So it's a challenge. Again, we've got a safe system snippet on that. And Kathy, you can probably put that into the resources if it's not already there.
Yep, all good. Done.
Awesome. Okay. I'm going to be a bit quicker because we actually have a little assignment for you to do at the end of this. It's a fairly quick assignment. It's not going to take up your weekend, but I do want to have time to introduce that. So I'm going to go a little bit quicker here. I just want to talk very briefly about this intersection, which is a high-speed, 100-kilometre-per-hour intersection, a very rural environment, obviously, but it's got some challenges. It's got properties pretty close up to boundaries here. This is a telecommunication exchange, and the region's looking to improve safety here. It's got a pretty bad crash history. Not that you're driven only by crash history, but it is a pretty good indicator you want to do something. High speed. So the region's like, okay, well, we'd love a roundabout here. And they look to Part 4B and they design their roundabout up, and it's got reverse curves on the approach, big reverse curves and this big roundabout area. They've got to relocate that. They've got to buy up all of this land and buy this land and buy part of this. And they don't like it because it's taken up their front garden. And, lots of the usual challenges you get, and service removal, and the price tag comes in near $10 million or something like that. And they go, we can't, we can't be doing this. And so then they go, oh, well, let's go and we'll do a right turn lane, and we'll do some rural intersection activated warning signs. And that's going to reduce the chance of a crash, absolutely. But it's really not doing anything for that severity, is it? So again, in a different environment, credit to the region for really drilling and working on saying, what can we do to this location to reduce the speeds and the angles and make it less severe? And so there are the crashes. So they said, what about a smaller roundabout? What about a little roundabout? And then you remember I said, well, what about a large vehicle tracking around that roundabout? How's that going to work? Well, the roundabout itself is very small. And then they have a concrete apron, an area that a large vehicle could sweep over, like we saw in that very urban little UK example where they could go over it. And then they said, why do we do these big reverse curves on the approach? Can we do, that's taking up a huge amount of land and cost and everything like that. Could we slow vehicles down in another way? I mean, that's what a reverse curve is there to do. It's to slow down, to wake up, to get people ready. There's, intersections, chicane them in. So again, they've looked, could we do raised platforms on the approach to this? And so without getting into the details of this, and again, anybody interested in the detailed design of this, happily send you the detailed designs of this. And we've actually just finished and published some guidance for the Department of Transport on compact roundabouts and compact roundabout design, which is pretty exciting. And there it is. And here's some ramp grades and all sorts of good stuff. But they built this one. And you can see there that they're doing a very sort of shallow ramp on the approach. It's quite long because we don't want larger vehicles to be sort of half up and down, and up and then down. You can probably see there, in fact, I think if I hit play, it sort of moves a little bit forward. You can see the inner radius of the roundabout, very tiny little thing, isn't it? It's a little, the vehicles can track around it. And, this came in under half the cost of what a full-size roundabout would be. They didn't need to move this beast, which was going to cost like $1.5 million in its own right, to just plonk it out here somewhere. Incredible. Anyway, so pretty exciting, again, innovation in thinking. And it's all around that determination to not just say, oh, well, we'll reduce the likelihood of crashes a bit in our usual way, a bit of a right turn lane, some warning signs. I mean, that's good. We want to do that if that's the absolute only option, but pushing hard to try and get that severity reduction down is really quite exciting, quite amazing. And again, this is performing beautifully. I mean, these are vehicles coming in at high speed to raise safety platforms and working beautifully. Noise, you think, oh my God, noise? No, they're working well. They're not too concerned. Let's do this. Do we have time? Yeah, let's do it. If it's there, maybe it's not there. That'll save us. Quick one. I'm only going to give you 30 seconds on this. True or false? Traffic signals are not safe system. True, false, or unintelligible question. And meaning that doesn't make any sense. Like your question doesn't make sense. It's an unintelligible question.
I think we're going to close it there, Ken.
Okay. So the traffic signals themselves, it doesn't kind of make sense because it's not about the signals, is it? It's about the environment, the context, the speed. So unintelligible question would be a good answer there for that reason, but also for the second reason of I don't tend to talk in binary of safe system. Aligns highly with safe system principles, doesn't align highly as another thing. So I wouldn't talk particularly about that is safe system, that is not safe system. But I could accept true if you had that vision in your mind of that high speed signals without any race platforms or anything to slow vehicles. And I'll accept false as well in the sense that it's not the signals that are either safe system or not, or align highly or don't align highly. It's the context and what's the speed and the like. So slightly bit of a trick question. But the reason I do put that in there is that occasionally people come out of this course with this impression that you cannot put traffic signals in to create a safe system environment. And that's not true. I mean, you just need to do it in the right context and get speed management in place, or if speeds are already low and within those tolerable levels, great, it's fine. So lane departure. I mean, we know that vehicles depart their lane. People fall asleep. They look at their phone. They look behind them at the screaming kid. They drop their coffee in their lap. A kangaroo or a kiwi jumps out into the middle of the road. You know, there's just endless reasons why people leave the road, okay, or leave their lane. They leave their lane, then they hit trees, they hit power poles, they hit culverts, they roll over, they cross the center line, they hit other vehicles. And we know just all along these sorts of routes where we have a center line and we have edge lines, and that's kind of it, and maybe some sealed shoulders, maybe a little bit of audio tactile center line and edge line. We know people are leaving the road, and it's not like you say, oh, there's a little curve here, that's where they're all going to leave the road. No, just dead straights, and they just fall asleep and leave the road and run off the road. And it's everywhere on our high speed network, and you know your state highways are just full of it, dotted along there. Maybe there's a bit of an increase in risk of run off road there, but there's lots of risk of run off road there as well. And so you just see a massive amount of your network like this, which is, you know, so inherently far from the safe system, high safe system alignment, because we've got head-on crashes we know can't happen by more than about 70 kilometers per hour without high likelihood of death. We know run off road into trees, we're talking around 40 kilometers per hour, or rollovers maybe about 50 kilometers per hour. we are relying on every one of these individuals not making mistakes, and unfortunately they do. And we know that, these side impacts into point source hazards are hugely dangerous. We talk about 29 or 32 kilometre per hour side impact pole test to get a 5-star ANCAP safety rated vehicle. I mean, that's what vehicles are going to. Vehicles are really not doing much over about that 30, 40 kilometre per hour side impact. And so we're in trouble there. Now we know vehicles roll over as well. So clearing out those point source hazards, the trees, the power poles and the like, that helps us. But vehicles still roll over and go beyond anything that we've cleared. And so this is why the idea of a clear zone has been sort of eliminated from the Australian Code of Road Design Part 6. So clear zones are not something we do anymore. I mean, yes, we know it's less risk if you've cleared out your point source hazards, your trees, your power poles, but it's not without risk. And we know that rollovers will continue to occur. And I've got a few graphs on that, but this is probably the most prevalent one, or sorry, the most pertinent one, where we know that as you create cleared areas of hazards or clear zones, you reduce the chance of crash, but it never gets to zero. We still sit in there with this decent residual of death and serious injury. Plus, we can't clear. It's so expensive, and native vegetation, and you rarely ever get those on clear zones. But now we know that we have, I'm going to jump through a few slides here, we have better than creating these sorts of road environments. This is the way we used to design a road to best practice. Big sealed shoulders, and then all your trees had a nominated clear zone. Big, wide, medium. But we know there's heaps of death and serious injury on these roads. People fall asleep, they go well beyond the clear zone, they're into trees, they make it to the other carriageway, they crash. So if you've got State Highway 1 and you're going to duplicate it to this, it's not the safest outcome we can get. And it costs a massive amount of money. Right? New Guide to Road Safety Part 6 is better in this sense. And we start to understand that we get far better road safety outcomes when we do barrier, barrier, barrier. Now, very simplistic cross sections here. I mean, so much detail we could go into, but just that idea. And look, the area taken up is so much smaller. You don't need this massive. That is going to be a safer outcome. A sort of alignment with safe system principles from high down to low, you can see there a little, it's sort of very conceptual sketching, but the idea is there. And I'm not going to go into detail of it, but really these cross sections where we have full containment, you can call it the bumper bowling of roads if you want to. It just acknowledges people are going to fall asleep, they're going to leave their lane. We're going to try and stop them doing that, but they will. And let's have a barrier there so they roll along that. The implementation of this becomes very tricky, and your continual barrier systems and how you place them and how far off the edge. So you need to be very thoughtful around all of this. And there's lots more good guidance coming out, lots of learnings from different jurisdictions that have gone berserk with continuous barriers like us in Victoria. And I'll give this final sort of case study example before I take any final questions and we show you your little assignment. It's in the same sort of vein of thinking, how do we manage energy? And this is a crash that happened into a power pole, but the power pole had a raptor, which is a device which is pretty ingenious, in my opinion, that goes around the pole. And the device is not just like a cushion, like a football goalpost padding, like a rugby goalpost padding. No, it does have some cushioning to it, but it's not connected to the pole, right? So what it does is it actually, as a vehicle hits it, it rotates, right? Due to that sort of angled nose and things like that. As the vehicle hits it, it rotates and it sort of pushes the vehicle along. So manages energy, rolls the energy rolls the vehicle on through, dissipates the energy. And I just love the design thinking of these people to say, how do we, okay, absorbing energy is bloody hard in, they've got this vehicle coming in at high speed and we've only got a small amount of area to absorb that energy. How could we roll and rotate and move the energy along? I just love it. I think it's brilliant thinking. And it came to play in this one where the old vehicle with 4 male passengers at 2 a.m. hit the power pole. Results without that cushion, according to all the forensic investigations, would be death. High levels of serious injury for all of them, for sure. But it rotated, it took a fair bit of the energy, knocked the power pole down as well, but rotated it, pushed the car off, and minor injuries was the worst of that. I mean, in a 1-star vehicle, if you're lucky, and amazing to come out of that. So I think that just sort of energy management is a pretty impressive thing. And yeah, they made a mistake. All right. And they were doing stupid stuff. And we can jump up and down and say, oh, they shouldn't do it and all that. That's what they do. We will try to address that through other ways. But amazing, again, example of safe system in action there, where the infrastructure meant that they're all living a normal, healthy life now and hopefully contributing to society and, got a big shock and learnt and, but yeah, I think it's pretty good. Okay, that's probably enough from me because Kathy, I want time to answer any questions, but also explain this exercise in a bit of detail. So anything I need to deal with?
Yes. Earlier, Ken, when you showed us that little, I'm going to call it the little roundabout with the ramps.
Yeah, compact roundabout, yep.
Yeah, that's the one. Interested by the truck overturning warning signs on the approach to the roundabout. Also, with the background of our heavy haulage groups being often caught up by smaller radius roundabouts for tracking, even with mountable aprons with limited lip height, and grades.
Yeah, I think we'll just upload the design guidance that we produced for the Department of Transport, which has now been made public because there's a lot to that. There's a lot to those questions. You really got to understand your vehicles. The truck rollover signs were really we did truck modeling, truck rollover modeling, everything was fine, but it was just a little bit of a concern. And being the first sort of compact roundabout and road safety platforms, they were sort of put out there as prior. I don't think you need them. We haven't had any rollover or any concern from that perspective, but they were a bit of a, because it was the first installation measure to make sure that, So I'll make a note here to upload that design guidance for compact roundabouts. I just popped in a paper actually for the Australasian College Road Safety Conference in New Zealand in September, where we're going to present on that if they accept the paper with some colleagues. So hopefully I'll be there and we can talk it out in person, but we'll upload that now. Okay, Kathy is in there in Moodle. And where have you gone to, Kathy? Have we lost you?
No, sorry, it's that mute system. Gone to module 2, and I've popped a few things in there already, and we'll pop some more things in there. There was that snippet on left turn slip lanes you spoke about earlier, the Austroads guide on effectiveness and implementation of raid safety platforms, and a bonus race safety platform webinar for anyone who wants to check that out. That was run by Austroads a little while ago. But we're going to have a look at the module 2 assignment, which is a little assignment for you to do. So you just jump into there. I think you can see my version. So your version might look a little bit different, but the assignment should look the same.
Okay, so as that comes up, hopefully we see it there.
Obviously my computer's lightning fast, isn't it?
Yeah. I have to get you a new computer then.
Yeah, it's on order, Kim.
It's on order.
There we go.
There it is.
Oh, there it is.
Oh, yeah, there it is. Okay. So what we've done there is we've put a Word document. So the first thing you're doing is download that Word document, right? And you'll see there the instructions, which is nice. So you can always look back to that. But anything highlighted in yellow, and this is a theme throughout this course, anything highlighted in yellow is what you're going to need to action. So there you go. You put your name. And then it says link to your intersection via Street View or Google Maps or something like that. And by your intersection, what we're saying is you pick any intersection you want. Could be the one outside your house, could be one you've got concerns with, could be one you're working on, could be one you remember from a holiday, but you're just going to find that via Street View or look out your window or whatever it is, and you're going to give us a link to that intersection so we can have a quick look at it via Google or the like as well. So your name and that. And then what's on the next page? Oh, more highlights. Okay, so all we want you to do is put in there exposure between 1 and 3 factors that influence or increase exposure at that intersection you've chosen. Okay, so that could just be, well, it's got the number of legs, or it's a major arterial, you know, it's got lots of vehicles coming through there. It's got a shopping center and lots of pedestrians crossing. Yeah, this is all about what's generating the numbers of vehicles, number of pedestrians. So you could put 1 thing there, 3 things, up to 3 things. Then you're going to go over to likelihood. And you're going to say, what are 1 to 3 things that are increasing, influencing the likelihood of crashes? Okay, so this could be, oh, sight lines are blocked, or there's not good sight distance to the intersections, or it's confusing, or the signs are faded, or the speeds are high, or, you know, the line marking is confusing, or you know, what are things that are influencing the likelihood of crashes at that intersection between 1 and 3. Then you go to severity. And you go, okay, what is influencing the severity of crashes at this intersection? Okay, so this could be speeds, heavy vehicle percentage, the vulnerable road users, whatever it is. And you put between 1 and 3 there based on your analysis of the intersection. Angles, it could be angles, it could be anything. And then we want you to go through and say, well, what's 1 thing that we could change to reduce the exposure at this intersection, the exposure to crashes? Could be closing a leg, could be, you know, anything. What's something that would reduce the likelihood? Just 1 thing we're looking for in each of these, just 1. 1 thing that would reduce the likelihood and 1 thing that would reduce the severity. So kind of similar to what you were doing with our example that we worked together through today's module. You're doing it for your intersection and you're categorizing it out. You're also looking for the factors, the ones that are shaded, I suppose, a green row is, you know, the factors that influence the risk at that intersection as it currently stands. And then the white row is things that you could change. And I'm not limiting you on budgets or anything. This one, you can do anything you want. You can suggest anything you want there. And so you'll be marked on this, right? And you'll be marked on, have you categorized things correctly? Have you got those categories right? Okay, we will have a look at the intersection as well and see whether we think it's a good, you know, idea or not. Does it make sense? But your primary marking is, did you categorize things right? And if you've completely categorized things all wrong, well, we'll give you a low mark and you'll have to do it again because you need to get that 80%. But you don't need to spend a long time on this. It can be very quickly done via Street View. You can just look at it, add a few dot points in there, PDF it, and upload it, which Cassie, I think, will show you now, maybe. Oh, Kathy's going to become a student. There we go. And then you go. So, yeah, save it on your desktop or whatever, PDF it, and upload it, drag and drop it, or hit the upload button, pop it in there, and hit save changes, submit, and your assignment will be in. There is a quiz as well today, isn't there, Kathy?
There certainly is, Ken. And so if you can get that one in before the next session, which is next Tuesday, that would be good. I think, Ken, you probably like to have a look at them and mark them before the next session. And then that way everybody knows that they're categorizing things right and so on. And there's the quiz there as well, session 2 quiz.
Yeah. So at the start of next session, I probably won't have got to marking them all as they're coming in, but I'll have had a quick look at how people are going. We'll be able to talk through any common issues I'm seeing, and we'll probably also get a volunteer to maybe walk us through their analysis, and we'll pop the street view up and we'll have a bit of a chat about exposure, likelihood and severity, analysing this. So we're stepping you nicely into that end goal of being able to get you to be a safe system assessor, and this is a pretty good one. And as we say, relatively quick exercise here. If you were starting to spend hours on this, you've gone way, way, way too far. Really, I mean, this is sort of 15, 20 minutes at most exercise. Okay. Any questions?
There's no questions just yet. So this is your last chance to ask any questions. Otherwise, I think everyone's got the hang of the Moodle quizzes and that sort of thing. So you just need to jump in after the session and complete those, but they are open throughout the whole course. So there's no close date on those. So don't worry too much if you can't get to it after each particular session. I think that might be it. So we might finish 3 minutes early, and that gives people a little bit of time for the quiz.
Thanks, everyone.
Thanks, Ken. Thanks, everyone. Bye.
Bye.